Okay, let's try this limiting reagent problem. That would be good practice for the quiz. So I'm just going to highlight my coefficients here. So that's a 6, right? That's 2. And there's a 1 that's also understood here, right? So there's a 1 right here, right? So there's a 1 in front of that. We'll just highlight that as well, right? So pay attention to the coefficients that are used in these problems, right? So we have a 1 to 6 to 2 to 1 ratio of the reactants and the products, right? So those are the molar ratios. Okay, so let's solve this problem. So in these type of problems, I'm usually going to list kind of in order here: mass, molar mass, and moles. Right, and our little symbols for those are M, large M, and N. We also know that N is little m over big M. Okay, now I'll just list what I'm given here. So 15.00 grams, 10.00 grams, right? And so one of these is going to run out first. And it's not really obvious at all which one's going to run out first, right? So we know that we have to convert this. These come together in molar ratios, so we need to convert to moles. So we need the molar mass. So this is 150.14 grams per mole, and water is 18.02 grams per mole. Okay, and then so moles over molar mass is 0.099967. And here we have a 0.5549. Okay, and now what I'm going to do, and I'm just going to switch to a different color. I'm going to do my limiting moles test. Limiting moles test. And so when I do a limiting moles test, I take the moles that I'm given, moles that I calculated, and I divide by the coefficient. Right? The coefficient in this case is 1. Right? And I'm comparing that versus 0.5549, right? So if you take the moles given, and again, so this is more moles than this, but is it 6 times this, right? So for every one of these, I need 6 of these, right? So by dividing by the coefficient, we can just compare them directly, and the lower one is the limiting one. Okay, and in this case, it's, right, so 0.09967 versus 0.09248. Right, so pens are, there we go, 248. Right, so that one is lower, therefore limiting. And so that answers the first question, which is, what is the limiting reagent, right? So therefore, the limiting reagent is water. And this is the actual number of moles that we have that is limiting. This moles will run out first, right? And also will determine how much of this is made, which is the next part of this question. Okay, so what is the maximum mass of aluminum hydroxide, which can be formed from these reagents, right? So going to say since water is limiting, H2O is my okay, so my moles of aluminum hydroxide is going to be equal to my moles of water, 0.5549, right? So moles water, right? Water is the limiting reagent. It will be determining how much moles of everything gets made, right? And then so I'm going to multiply by the molar ratio of what I'm trying to find, right? So I'm trying to find aluminum hydroxide, right? And so I'm given water. Pen, get back to me. There we go, water. Okay, and then this is, right, so based on the coefficients from the balanced chemical equation, is a 2 to 6 ratio, right? I found those numbers, that 2 to 6 ratio here. It's a 2 to 6 ratio in this reaction. Okay, so that'll give me the moles, which is 0.18. 497, and just keeping a few extra digits always as we're doing these in-between steps, right? So you want to keep extra digits until your final answer, right? And so that's the number of moles of aluminum hydroxide, and therefore the mass of aluminum hydroxide, which is what we're ultimately trying to find here, is equal to N times M, which is equal to 0.1849, 79, right? So that's my moles aluminum hydroxide times the molar mass of aluminum hydroxide, right? So 1 aluminum plus 3 of those is equal to 78.01 grams per mole, right? And so we notice that moles cancel. My answer is in grams. So 14.43 grams AlOH3. Okay, and so we'll leave it there for now.